So welcome everybody to our latest video looking at bearings, and in this video we'll be going over some commonly asked example questions that cover a range of things that involved in bearing questions that you'll be asked to find both in textbooks and exams. Now the worksheet which I will work through is available in the description below for you to click on and download and work through either before watching this video or while during watching it. So here are some top tips when answering questions related to bearing. So the first one is always remember the 3 rules of bearing. So remember that the first rule is that you always start from a north line. Second rule is that you always go in a clockwise direction. And the third point is you always give bearings as a 3-digit number. The second one is you only use the protractor or angle measure when diagrams are drawn to scale. So whenever you get a diagram, always look for that little sort of comment that says that diagrams are drawn to scale, and if that is the case, then you will not be able to use a protractor to work out your bearings. Also, the third point is always highlight key information and understand what it is that you are asked to find, and that again is really important. It's very easy to guess what questions are asking you to do, but the wording can be very tricky. It can be written in certain orders as what's given or shown in the previous video on bearings. The fourth one is draw a diagram if one has not been drawn for you. Now more often than not a diagram will be drawn for you, but if it isn't, definitely encourage you to draw a diagram. And other linked topics are scale drawings, Pythagoras theorem, trigonometry and loci. So these are things that can be linked in with bearing questions. You've also got angles on parallel lines, which is also worth noting, which is what I'm going to do now, and just add that in just to show how unprofessional this video is. And angles on parallel lines, and also you've got other angle properties of angles on triangles, etc. Now here is a copy of a worksheet that I will go through, which will go over some of the commonly asked questions in textbook, tests and exams, and I'll attach a link where you can download this worksheet for you to print off and have a go at these questions before or during I talk through them. So again, I'm just going to go through a couple of these questions. So a lot of them do involve some basic, starts off relatively basic with just finding out angles, and also what's always worth noting is knowing whether an angle is obtuse, acute or reflex as mentioned in the previous video. You've also got some scale drawing questions, and again a massive range of basic questions, low level mark questions, and then it moves on to more complicated ones where you're looking at 2-3 marks, and then it slowly moves on to a more high level questions, which then involves looking at trigonometry, scale drawings and etc. So with question 1, what we're being asked to do is to measure the bearing of A from B. Now it's important that when reading these questions, this is where we're starting from and A is where we're ending. So the actual angle that I've been asked to find is this angle here, which is an obtuse angle. Now measuring that angle with a normal protractor is going to be somewhat a little bit difficult. So first thing I'm going to do is I'm going to draw a straight line from my north line. Now I know that this angle here is going to be 180 degrees. So the only angle I've got to find, or measure I should say, is this angle here. So again, putting my centre of my protractor on the centre point of B, putting my 0 on the line that is going away from the north line, so heading south, and I get that that angle there is going to be, and using the outside numbers of where it starts from 0, I can see that it's 50 degrees. So this total angle, I just showed in the rest, this in pink, is going to be 180 plus 50, which gives me an angle, or bearing I should say, of 230 degrees. Now alternately, what I could have done is I could have measured what this angle here is, and if I get my protractor, again placing the centre of the protractor on the point B, 0 on the line, I'm going to use the inside numbers rather, and I get that to be 130. So I could do 360 minus 130, which gives me the same angle of 230. Now in question 2 it says that in the diagram point A marks the position of Prestwick. The position of Radcliffe is to be marked on the diagram as point B. And it says question A, it says on the diagram mark with a cross the position of B, given that B is on a bearing of 320 degrees from A and that B is 6 centimeters from A. So again, the first thing we need to establish is that it's 320 degrees from A. So what I need to do here is I need to draw a reflex angle of 320 degrees. Now this is going to be a little bit difficult However, to draw a reflex angle with the protractor, it's going to be 320 minus 180, which is going to give me 140. So what I need to do is, from this point here, is measure going in a clockwise direction from 0 at the bottom. I'm going to measure 140 degrees, which is just there. And I can then draw my line going from there. So this is 180 and this is 140. And altogether this would give me a bearing of 320 degrees. Alternately, what I could have done is I could have done 360 minus 320, which equals 40 degrees, and then measured in an anti-clockwise direction 40 degrees, and that also would have given me that bearing. Now the next part of this says that B is 6 centimeters away from A. So again, I'm going to measure using my ruler 6 centimeters. And put a little dash to where the line is, and I'm going to mark a little cross as requested and label that B. And there is my final answer. Now the second part of this question says that the scale of the diagram is 1 to 50,000. Work out the real distance 6 centimeters represents. Give your answer in kilometers. Now what this scale represents is that 1 centimeter is equivalent to 50,000 centimeters. So therefore 6 centimeters will be 6 times 50,000, which gives me an answer of 30, and then 1, 2, 3, 4 centimeters. So it's going to equal, so 600 centimeters on this diagram is actually going to be 300,000 centimeters. Now from this, what I now need to do is I need to convert this into kilometers. Now first things first is I know that to convert this into meters, so centimeters into meters, I need to divide by 100. So if I divide 300,000 by 100, then what I get is I'm going to get 3,000 meters. And then to convert meters into kilometers, I need to divide by 1,000. So if I divide this by 1,000, I get my final answer of 3 kilometers. And there we go. Now looking at question 3, it says work out the bearing of B from P. So looking at this, P is my start and B is my end. So looking at the diagram, the angle that I've been asked to work out is going to be this angle here. Because here for my P, my north line is drawn, so going in a clockwise direction, and that will be the bearing of P to B. Now, because the diagram is not drawn to scale, that therefore means that I cannot use my protractor. So for this, I know that all of this angle, if I just highlight this in pink, is going to add up to 360, including that side. So for this angle, all I need to do is do 360 minus 138, and that will give me an answer of 222 degrees. Now the next question then says to work out P from A. Now from this, A is where I start and P is where I want to end. So looking at my diagram, first things first, I need to draw my north line. Again, trying to be as accurate as possible. And it's this angle that I'm trying to find. Now for this, obviously it's not going to be drawn to scale, so I can't use my protractor. But one thing I can do is if I extend the line going from P to A, I know that this angle here is going to be 63 degrees because it is a corresponding, or an F angle, from this angle here. Now I know that this part here, if I just highlight that in pink, is going to be 180. So then the bearing of P from A is going to be 63 plus 180, which gives me an answer of 243 degrees. Now moving on to question 4, The question is asking me to measure and write down the bearing of Q from P. So Q from P, so P is where I'm starting and Q is where I'm ending. So from the north line of P, I'm going to go in the clockwise direction, and it's this angle here that I need to measure. So again, getting your protractor out, putting the center of the protractor on the point of P, the north line on 0 degrees, and I'm measuring this angle here, and I work out to be 38 degrees. So giving that as a 3-digit number is going to be 038 degrees. And there's my final answer. Moving on to question B, it says find the bearing of T from R. So again, this is where R is where I'm starting and T is where I'm ending. So starting at R, which is here, I'm going to go in a clockwise direction until I get to the line that goes from R to T, and it's this angle here that I need to measure. Now if this is 90 degrees, then this angle here must be 270 degrees. So looking at question 3, we've been asked to measure and write down the bearing of B from A. Now B from A is going to be this bearing here, which is an obtuse angle. So let's call that in pink. So it's this angle here that we're asked to find. Now again, this is an obtuse a reflex angle, so it's going to be very difficult for us to measure with our 180 degree protractor. So other ways you can do this is you could draw a straight line from north. We know that this is going to be 180, and then all I then need to do is measure what this angle here is going to be, which I make it out to be 150 degrees. So all I need to do is add 180 plus 150, and I get the answer of 330 degrees. Alternately, what I could do is measure the angle that I don't want, which is this in the middle, and I make out that is going to be roughly around about 30 degrees. So it's going to be 360 minus the angle that I don't want, which is 30 degrees, and it gives me the same answer of 330 degrees. Now part B then says on the diagram draw a line on a bearing of 107 degrees from A. So this point here is A. So again, I'm going to get my protractor, center of the protractor on the point A, 0 on the north line. I'm going to use the outside numbers and measure where 107 degrees are. And 107 degrees are kind of in my answer, is roughly about there. And I'm just going to draw a straight line from there, and that there would be my line of where B is. So that's my answer for part B. So moving on to question 6, it says that this is a map of Northern England, and you can see here we've got a range of cities and towns in the UK represented on this map, and it says here we've got a scale of that 1 centimetre represents 10 kilometres. Now the first question says that a plane flies in a straight line from Preston to Stoke-on-Trent, and the question is asking us to find how far does it fly, give your answer in kilometres. So what we need to do is use this scale to our final answer. So the first thing I need to do is make sure that I'm selecting the 2 correct locations, which is Preston and Stoke-on-Trent. So Stoke-on-Trent is here, Preston is there. So all I'm going to do is going to draw a straight line being as accurate as possible from those 2 destinations. And then using my ruler, I can see that it's 9 centimeters. So it's going to be 9 centimeters. I need to multiply that by 10 because 1 centimeter represents 10 kilometers, and that's going to give me a final answer of 90 kilometers. Now the second question then says measure and write down the bearing of Preston from Manchester. Now the key thing to note is that although Preston is mentioned in part A, Manchester is a new location, and Manchester is where I'm starting and Preston is where I am ending. So from Manchester, what I'm going to do is I'm going to draw a north line, and let's use the black pen for that, trying to be as accurate as possible in that north line, and then I'm going to draw a line going from Manchester to Preston. And lo and behold, that it's this angle that I need to measure. So it's going to be a reflex angle, and so my answer needs to represent a reflex angle. Now again, there are several ways in which you can do this. You can continue from your north line and know that that is 180, and then the only thing you then got to do is measure the remaining part of that angle. So again, putting 0 on the line, it works out to be around about 135 degrees. So adding those two numbers up, I'm going to get an answer of 313 degrees. And yeah, so it's going to be 300, which if I just move the page up a little bit, that's going to be 315 degrees, and that's 180 plus 135 gives me that. Alternately, what I could have done is I could have measured this angle here, which again with my protractor is going to be 45 degrees. So an alternative way would be to do 360, take away 45, which gives me the answer 315 degrees, as it did in the original answer. So for this, all I'm going to do here is just write 315 degrees. And looking at question 7, it says the diagram shows the position of Colwyn Bay and the position of Blackpool. It says that the bearing of a ship from Colwyn Bay is 032 degrees and the bearing of the ship from Blackpool is 290. In the space above, draw an accurate diagram to show the position of the ship. Mark this position with an X and label it S. So the first thing we need to do is to mark the bearing of 32 degrees from Colwyn Bay. So again, what I'm going to do now to make your life a little bit easier, what we're going to do is get our protractor and we're going to put the centre of the protractor on the point of Colwyn Bay, and I'm going to measure 32 degrees. And we need to be as accurate as possible to mark where 32 degrees is. And once we've made our mark, what we then need to do is to draw our projection line from Colwyn Bay to that line, which I'm just going to find a pen. Again, hopefully you'll be using a pencil. And there we go. And we're just going to mark this angle as 032 degrees. Now, the next thing I then need to do is to mark the bearing of 290 from Blackpool. Now again, this is going to be a little bit difficult with a 360 degree, a 180 degree protractor. So what I then need to do is think to myself, well, okay, if I just do a little diagram, 290 is going to be somewhere in that direction. So this bearing here is 290. So the angle that I don't want is going to be 360, take away 290, which equals 70 degrees. So if I mark 70 degrees, going in an anti-clockwise direction, again using the, let's use a different colour pen, so that's going to be here, and draw my projection line. And what I'm wanting is where those two lines cross, just about cross, because that pink line should have been drawn a little bit longer, but it's the point of where we intersect, and this angle here is 290 degrees. Now again, if I just extend that line a little bit longer, like so. So what we're looking for is where the 2 points intersect, and they intersect at this point here. So I'm going to mark with an X and label this S, so that's where the ship is going to be located. Now question 8 is very, very similar to question 7. It says the diagram shows the position of two ships A and B. A shape C is on a bearing of 064 degrees from A, and ship C is also on a bearing of 290 from ship B. In the space but above, draw an accurate diagram to show the position of ship C and mark the position of ship C with a cross and label it C. So what we're going to do then is to measure that first angle. So first thing we need to look at is make sure we're establishing where this is. So we're looking at a bearing of 064 from A. So again, I'm going to position my protractor centre on the position of A, 0 on the north line, going in a clockwise direction, and I'm going to measure 64 degrees, just about there. This time I'm going to make sure my projection line is a little bit longer. And again, making sure you are using a ruler. I'm going to just extend that projection line. Now the next thing I then need to do is to mark this angle here. Now 290 again is it's exactly the same as the previous one. So again, an angle of 290 is this angle here. So the angle that I don't want is going to be 70 degrees. So if I measure 70 degrees from point B, going in an anti-clockwise direction. So again, I'm going to put my protractor center on the center of the protractor, or point B on the center rather. Going in an anti-clockwise direction, I'm going to use the inside numbers to mark where 70 degrees is. And then I'm just going to use the straight edge of the protractor to mark where that's going to be. And it is always good practice to label the angles that you've measured. So this is going to be 064 degrees, and this angle here is 290 degrees, or measure that this angle here is 70 degrees. Now where the ship C is going to be, it's going to be at this point here. So I'm going to mark it with an X as required and label that with a C. Now with question 9, the first thing to recognize is that this diagram is not drawn to scale. So I don't need to, although it's a bearings question, I don't need to use my protractor to measure the actual angles, because that's going to be incorrect. So the diagram, it says that it shows the position of each of 3 buildings in a town. The bearing of the hospital from the art gallery is 72 degrees, which is marked just there. It says that the cinema is due east of the hospital, so there's my due east. So just colour that in pink, so that's my pink information. This here is my purple information, and it says that the distance from the hospital is equal to the distance of the cinema, or hospital to the cinema. So that's where we've got these 2 lines here. And the question is asking us to work out the bearing of the cinema from the art gallery. Now it's always important to recognise what it is you're actually trying to find. So the question is asking us to find from the art gallery, so this is our start, and the cinema is where we end. So the actual angle it's asking me to find is this angle here. Now I know what the majority of that angle, which is 72, is, but I don't know what this little part of the angle is here. Now another thing that I recognise, that this is an isosceles triangle. So if I just colour this angle here in purple, then this angle here is also going to be in purple. Now with regards to this particular question, which is a little bit challenging, one thing I've got to recognise is that because it's an isosceles triangle, these 2 angles are going to be the same. So what I need to try and do is find out what this angle here is. Now before I do that, one thing I've got to recognise is that the angle from the hospital going in an anti-clockwise direction to the art gallery, so this angle here is co-interior or supplementary. It's like a C angle. So to work out what this angle here is, it's going to be 180 minus 72, which equals 108 degrees. So this angle here is 108. Now all of this needs to add up to 360 because angles are around a point. So to work out what this angle here is, all I then need to do, let's do that in different colours so it stands out. So this angle here is going to be 360 minus 108 minus 90 degrees. And the answer I get from that is going to be 162 degrees. Now because this is a triangle, and it's this angle that I'm looking from, an isosceles triangle, then to work out what the actual angle is going to be, well, it's going to be 180 minus 162, which is going to give me 28. And it's going to give me 18 rather. So then the angle, so dividing that by 2, so 18 divided by 2 is going to give me 9 degrees. So this angle here and this angle here are 9 degrees. So from this I can then work out what this bearing here is going to be, which is going to be 72 plus 9, which gives me an answer of 81 degrees, and I need to write that as a bearing, so it's going to be 081 degrees. Now looking at our final question, again this question is not drawn accurately, so we know that we're definitely not going to be able to use our protractor to work out what this question is, even though it's a bearings question. So it says Ambertown, Bowtown and Comptown are 3 towns. Ambletown is 9.6 kilometers due west of Bowtown, and Bowtown is 7.4 kilometers due south of Comptown. Calculate the bearing of Ambletown from Comptown and give your answer correct to 1 decimal place. So the first thing we need to establish is what on earth are we actually trying to find. So here Comptown is where we're starting at, and Ambletown is where we're ending at. So if I draw a north line from Comptown, the angle that I'm wanting is this angle here. Now I know that this part of the angle is 180, so what I need to do is to find out what this angle here is, which I'm just going to label X. So the bearing that I'm wanting to find is going to be 180 plus X. Now this question, because it involves a right angle triangle, as you can see, if I just put that there, and also that it's due south and west, it's a right angle triangle, so it's going to involve SOHCAHTOA, as mentioned in the hint. So if I redraw this triangle with that there, this is my angle X that I'm trying to find. And again, if I just relabel these points, I've got Campbelltown here, Comptown here, and Bowtown there. Angle X and this length here is 7.4. So going back to your knowledge of trigonometry, so if you've not done trigonometry, then this question is going to be incredibly difficult, but there is a video that shows you to do this. So we need to work out the angle. So first we need to do is label the sides. So here, if this is the angle, so theta equals X, O is 9.6 and A is 7.4. So the trig ratio I need to use is going to be tan. So I've got tan theta equals opposite over adjacent. So calculating the sums, I've got tan theta equals, and it's going to be 9.6 divided by 7.4, which gives me, and then if I do the inverse tan of that, so inverse tan of 9.6 over 7.4, which equals X, that gives me an answer of 52.37 degrees. Now I'm going to go to 2 decimal places purely because of the question wants me to go to 1 decimal place, because I need to add on 180. So this is what X is. So if X equals 52.37, then the bearing is going to be 180 plus 52.37. And if I add that all up, I get an answer of 232.4 to 1 decimal place. And there is my final answer.